In this last problem, we're going to do two more types of questions with solving with more than one variable term. Okay? So notice these expressions, there's more than one variable term. We're also seeing some fractions. So let's see how we can deal with this situation. So first, here we have the quotient of x and 2 plus the quotient of x and 3 equals 5. Okay? So remember, our first goal, if there's nothing to distribute here, is that we want to combine like terms. Now these quotients may not look like terms, okay, but let's remember another way we can write these with coefficients. So let's write this down here. X over 2, we can think of that as 1 times x over 2, or 1/2 times x. Okay, so basically the idea is if you're dividing x by 2, remember in arithmetic that's the same as multiplying by 1/2. To divide by 2, you multiply by the reciprocal. And the same idea applies here. So we can write this as 1/2 x plus 1/3 x equals 5. Okay. So now it's more clear that these are variable-like terms. They're both x to the first power. So we need to add their coefficients. So we have 1/2 plus 1/3, and I'm going to do this work on the side. Okay, so remember, you give them a common denominator. 3/6 plus 2/6 equals 5/6. So now this equals, combining these, 5/6x equals 5. Now let's think about how we do this with the deconstruct and construction process. Okay? We could say that x, we start with x, it's multiplied by 5/6, and the result is 5. Okay? So for the deconstruct process, we would start with 5, we would divide by 5/6, and the result would equal x. Let's do this in a different color. So starting with 5, divide by 5/6, and this equals x. Okay. Now remember, dividing by a fraction, we reciprocate and multiply, so this is the same as 5 times 6/5. Okay, multiplying these fractions, the 5's cancel, and we get a result of x equals 6. So that's how we could use construction and deconstruction. Okay. Now notice, we could here think of doing this one step at a time. This is divided by 6, so we can multiply by 6. This is x is multiplied by 5, so we could divide by 5. But instead, we could just use this idea of the reciprocal that we used here. Now remember, our goal is to get 1x. We know what 5/6 of an x is equal to. We want to know what 1x is equal to. So what would we multiply this by? Well, if we multiply by 6/5, notice you can multiply across if you want to. Let's do that just to make it more comfortable. 6 times 5 is 30. 5 times 6 is 30. Okay. We also have to do this to the other side to balance the equation. Okay. And on this side, we'd have the 5's would cancel, or you could think of 30 over 5. And since 30 over 30 is 1, we have just x equals 30 divided by 5 is 6. And we get the same result. Let's look at the next one. Here we have the product of 5x, or the quotient of the product of 5x and 2 equals the product of 3 and x plus 5. Okay. So notice there's nothing to distribute here. Here we combined like terms, but they were both, and they were fractions, but they were both on the same side of the equation. Here they are not. Okay, so we're going to need to use the addition property of equality to make sure or ensure all of our x's are on the same side of the equation. Okay, so we don't want an x on the right-hand side. Okay, and we could say the same about the left-hand side. So I'm going to subtract 3x from both sides of the equation, okay, because I need to keep it balanced. And when I do that, it's like I'm removing 3x from the right-hand side and 3x from the left-hand side. Okay? But this we're going to need to write horizontally to make sense of it. So we have 5x over 2. It's not too straightforward how to do this, so we'll just write it as minus 3x equals 3x minus 3x is 0 plus 5 is 5. Okay. Now we can combine these like terms. Okay, remember, we could think of this as 5 halves x minus 3x equals 5. Now I'm going to do this fraction subtraction up here. We want 5 halves minus 3. So here's 5 halves. And to write 3 with a denominator of 2, that would be 6 halves. 5 minus 6 is negative 1. Okay. So combining these like terms gives us negative 1/2 x equals 5. Okay. Now that we only have one x term, if you want, you can use the construct and deconstruct process. So this basically says take x, multiply it by negative 1/2, okay, and the result will be equal to 5. To reverse this, we can start with 5, divide by negative 1/2, and the result is equal to x. So let's do this process. 5 divided by negative 1/2. Well, to divide by a fraction, we're going to multiply by the reciprocal, so 5 times negative 2 over 1, which is basically just 5 times negative 2, which is negative 10. Okay. So that's how we could use the construct and deconstruct process. Now let's look at this in terms of this equation and using the multiplication principle of equality. Okay, so I can multiply both sides of this equation by any non-zero number, and the equation will still be true. Okay. So notice, again, we want to use this idea of the reciprocal when we have fractions. So when we had 5/6, we multiplied by 6/5 to get 1. Okay. And notice here, if we have negative 1/2, we saw in this step, well, dividing by negative 1/2 is the same as multiplying by negative 2. Okay. Now we want to multiply by a negative because a negative times a negative is positive, and we want our x result to be positive. So let's multiply. We can even write it as negative 2 over 1. And we'll do that to both sides of the equation to keep it balanced. Now here, notice the negatives cancel, or we could write this as negative 2 over negative 2x equals 5 times negative 2 is negative 10. Okay. So notice the signed reciprocal worked. Negative 2 divided by negative 2 is 1, and we get x equals negative 10. Okay. So that was our last example, and just to review these two examples and how they were different, we needed to combine like terms, and we had fractional coefficients. They weren't obvious because they were written as quotients, so we rewrote them as fractional coefficients of the x terms. Then we used fraction addition to combine the like terms. Okay. And then we saw through the construct and deconstruct process how that corresponded to the principles of equality for both addition and multiplication. And also we learned how to use reciprocals to multiply both sides of an equation by a fraction instead of doing two processes where we have to both multiply and divide.